stuffing the 25mm automatic firepower of an AH-64 Apache attack helicopter into a 117cm handheld steel tube is a blatant violation of physical laws. Tipping the scales at a bone-crushing 15.1 kilograms while completely empty, the Barrett XM109 is absolutely not categorized as a standard sniper rifle. It is officially designated as an anti-materiel payload rifle, engineered exclusively to punch through reinforced concrete bunkers and shred light armored vehicles at a standoff distance of 2,000 meters. Weaponizing this apocalyptic level of kinetic energy created a catastrophic biological paradox for the United States military. We are going straight into the blueprints to dissect the mechanical engineering that transformed this shoulder-fired cannon into a ticking time bomb for the exact infantryman pulling its trigger. The first and most violently obvious engineering nightmare was managing the sheer kinetic thrust of the ammunition. When a 25 by 59mm cartridge detonates inside the chamber, the rapidly expanding propellant gases exit the muzzle at supersonic velocities, creating a backward mechanical thrust easily capable of dislocating a human shoulder and shattering the collarbone instantly. To mathematically mitigate this physical trauma, weapons engineers precision-machined a massive symmetrical V-shaped muzzle brake and welded it to the extreme end of the barrel assembly. This specific geometric design acts as an aerodynamic plow, physically forcing the high-velocity Mach 3 gas plume to violently vent outward at dual 120-degree angles, stripping away a massive percentage of the kinetic energy before it can travel backward down the lower receiver chassis. However, violently redirecting this hypersonic thermodynamic exhaust creates a localized overpressure zone encompassing the shooter's entire upper body. Firing the Barrett XM109 generates a brutal acoustic shockwave physically equivalent to detonating 0.5 kilograms of raw TNT high explosive exactly 30 centimeters from your face. The sudden spike in atmospheric pressure is so intense that firing this weapon without specialized double-layer military-grade hearing protection will instantly rupture human eardrums, induce severe micro-concussions, and cause immediate bleeding from the nasal cavities. But taming the muzzle blast was only half the battle. Controlling the remaining mechanical rearward momentum required completely dissecting and rebuilding the internal chassis from the ground up. Barrett engineers implemented a heavy-duty dual-spring recoil reduction system, an industrial mechanism functioning identically to the heavy hydraulic shock absorbers found on multi-ton industrial stamping presses. Upon the exact microsecond of powder ignition, the entire 44.5-centimeter fluted-forged steel barrel actually uncouples from its static position and violently slides backward exactly 60 millimeters deep into the internal housing of the handguard assembly. This mechanical displacement serves a critical life-saving function, deliberately delaying the physical transfer of the kinetic impact. By forcing the heavy steel barrel to ride backward against the twin heavy-gauge springs, the weapon stretches the sudden, violent recoil impulse over a few extra milliseconds, flattening the energy curve just enough to prevent catastrophic skeletal fractures. But the laws of physics always demand a blood toll, and the human body can only absorb so much kinetic punishment. During the highly classified Pentagon field testing protocols initiated in 2004, the raw biometric data logged from the recoil force sensors painted a grim picture of our biological limits. The United States military sets a strict, non-negotiable upper safety threshold of 60 foot-pounds of free recoil energy for any shoulder-fired infantry weapon. Even with the massive V-shaped muzzle brake redirecting the gas and the heavy sliding barrel assembly actively absorbing a significant percentage of the explosive blast. The residual kinetic energy slamming directly into the operator's shoulder consistently exceeded that 60 foot-pound maximum limit by a massive margin. Test shooters participating in the trials reported immediate drops in blood pressure, severe clavicle bruising, and a frightening temporary loss of motor function in their firing arm after enduring just a few consecutive trigger pulls. The weapon was slowly destroying its own operators, but failing to completely tame the external recoil was only the visible surface of the engineering nightmare. The extreme atmospheric pressure actively attempting to tear the weapon apart from the inside out during the internal ignition sequence was a metallurgical horror story just waiting to unfold. To contain the violent detonation of a 25mm helicopter cannon round inside a man-portable rifle, Barrett had to engineer a heavily reinforced rotary bolt mechanism. This is not standard gunsmithing. This is extreme high-pressure containment.
Pressure critical.
The bolt features massive, precision-cut titanium alloy locking lugs that rotate and mechanically bite directly into the hardened steel barrel extension. This aggressive locking action creates a temporarily hermetic seal, locking the breech tight just milliseconds before the firing pin strikes the primer. When that primer ignites the massive load of specialized nitrocellulose propellant, the internal chamber pressure instantaneously spikes to a terrifying 50,000 pounds per square inch in exactly 0.001 seconds. To put that catastrophic force into perspective, that is a localized compression load easily capable of crushing the reinforced titanium pressure hull of a commercial deep-sea submarine diving 3,000 meters below the ocean's surface. The structural integrity of the entire weapon relies entirely on the sheer tensile strength of those locking lugs. If those titanium components experience even a microscopic metallurgical shear failure under that immense stress, the entire upper receiver would detonate outward like an improvised fragmentation grenade directly into the operator's skull. The heat generated during this microsecond of ignition is equally apocalyptic. The internal chamber temperature flashes to 2,500 degrees Celsius, requiring a specialized fluted barrel design to rapidly dissipate the thermal energy before the weapon cooks off the next round in the chamber. Feeding these massive cartridges requires a specialized 5-round detachable box magazine, equipped with high-tension feed springs that must exert immense vertical pressure just to strip the heavy 25mm brass casings into the firing chamber. Before the payload can even be unleashed, the operator must conquer the immense ballistic drop of a heavy projectile over a 2,000-meter flight path. At exactly 15.1 kilograms empty, the weapon requires a massive bipod equipped with spiked feet just to anchor the chassis into the dirt. The trigger group is a heavy, 2-stage military design requiring a deliberate 6.5-pound pull, ensuring no accidental discharges occur when the shooter's hands are shaking from adrenaline and the concussive shock of previous shots. To calculate the extreme parabolic arc of the 25 by 59mm grenade, the weapon was paired with the Barrett optical ranging system. This integrated ballistic computer actively measures atmospheric pressure, ambient air temperature, and the exact upward angle of the rifle. The system instantly calculates the exact holdover required, adjusting the digital reticle in real time, so the shooter can drop a high-explosive payload directly through the reinforced viewing slit of a bunker 2 kilometers away. The projectile takes a full 4.7 seconds to cross that distance. The enemy will never hear the gunshot. The supersonic crack of the muzzle blast arrives long after the destruction has occurred. This specific 25mm projectile is an engineering marvel designed for pure localized annihilation. Unlike a solid lead bullet relying entirely on kinetic velocity to punch a hole, This payload houses a precision-machined concave copper cone packed tightly in front of a specialized high-explosive matrix. This is the weaponization of the Monroe effect on a microscopic infantry portable scale. Upon striking a light armored vehicle at a staggering 425 meters per second, the impact fuse triggers the explosive matrix in the rear of the warhead. The resulting internal blast wave instantly inverts and collapses that copper cone at supersonic velocities. The physical result is a hyper-focused jet of liquid copper plasma superheated to exactly 3,000 degrees Celsius. This searing plasma spear effortlessly punches through 50 millimeters of cold-rolled homogeneous steel armor plate, like an industrial blowtorch melting through a block of room-temperature butter. The armor penetration happens so fast that the kinetic transfer is almost undetectable to the naked eye. Once that 3,000-degree plasma jet breaches the interior crew compartment of an armored personnel carrier, the results are biologically and mechanically devastating. The sudden influx of extreme thermal energy immediately ignites any stored ammunition, permanently fuses the onboard electronic circuitry into useless dripping slag, and literally flash boils the ambient oxygen inside the vehicle. This chain reaction completely vaporizes the entire crew in precisely 0.002 seconds, leaving behind nothing but charred carbon and melted metal. The devastation inflicted at a 2,000-meter standoff range is mathematically undeniable, leaving burning steel and shattered concrete in its wake. But this exact extreme capability, this blatant refusal to compromise on destructive payload, is precisely the reason this mechanical masterpiece was permanently locked away in the military archives.
Shape charge dynamics.
The Barrett XM109 was ultimately rejected by the Pentagon, not because it was a poorly designed weapon system, but because it was an internally perfect machine that aggressively outpaced the biological limitations of human evolution. The physical skeletal structure of a standard infantryman simply cannot endure the required kinetic transfer to operate this portable cannon repeatedly without suffering permanent medical trauma. If military-grade powered exoskeleton technology had been fully developed and deployed 20 years earlier, allowing a hydraulic frame to absorb the kinetic punishment instead of a human collarbone, the global tactical infantry map would have been permanently rewritten. The XM109 remains a terrifying glimpse into a future where the line between an infantry sniper rifle and mechanized artillery is completely erased. Do not forget to subscribe to the channel and leave a comment below telling us exactly which mechanical death machine you want us to dissect and analyze next.